So the people who did the Unreal version will recognize this scene. This was just a very basic scene that had a default VR character that had hands, and you can like teleport around and grab things. And I don't think it did anything else, but the code is actually really simple, and it's important that you understand how they did that at the most basic level. So we're going to be doing some simple things today and on Wednesday. We're going to make a sort of shooting game where you just shoot at the blocks here instead of trying to grab them. We're going to teleport around the scene, but safely so that we don't get stuck in walls. We're going to grab things just by putting our hands over them and grabbing them. And finally, we're going to do magnetic grip, where you can squeeze and everything will come to your hand. So, yeah. First, we're going to start with just how do you make a basic VR character. The only thing that I added to the scene right now, well, I deleted the default character, and I added this just so that I know what time it is. Did I start OBS Studio? I did. All right. So, if you remember the very first lecture, I described how a VR character basically works. It's a root describing the calibrated tracking sensor. So when you calibrate things in the Oculus Quest, it has some area, and then it chooses a center point. That is the root. And then everything else is at the mercy of the tracking system. So you have like a root, a camera, and 2 arms. So we can implement that actually. I'm going to delete my old scripts. Actually, I'm just going to hide them. I'll put them in the ray guns folder. Okay, so I'm gonna create a class that is a pawn. In Unreal, a pawn is just something that can be controlled. In Unity, obviously, you make something by adding a script to it. I'm gonna call it Nick VR Pawn 2, because I already did this. By default, it's not really gonna have anything at all. Can everybody see like the screen clearly, even if you can't see most of the text? All right. So by default, it doesn't have anything except just the root. I'm gonna create a new root just so I can name it differently. This is going to represent our tracking area. So I'm going to call it VR tracking space. And this is some component that's tracked. In the Unity version, you had OVR camera rig, and the root of the OVR camera rig is the same thing. Except in Unity, since things inside of a game object don't have relative transform to each other, like they do in Unreal, in Unity you do this through parenting structures just in the scene. Does that make sense? Like in Unity, you parent game objects to each other instead of components to each other, like in Unreal. We'll see this in a second. But anyway, so at the most basic, you have a VR tracking space. You also have a camera, which represents the head. So I'll say head. And this is what you'll look through. And then Unreal has these classes that are called motion controllers, which work for any arbitrary VR device. It's just something that receives motion. And Unity has something similar, except they are, well, I'm going to show you something cool in a second. But in Unity, you have to use the API's own scripts to track something, like you need the Oculus-specific tracking scripts and so on. But in Unreal, you just have this, and you choose which thing it's tracking. So this is the left hand, or I'll say left controller. And there will be another one that is right controller. And I'm just going to tell the tracking system that it should be right. So the most basic VR character is just this. Everything is at the mercy of the tracking root. Now, if I do what I just did, which is mounts everything to the camera, what do you expect to happen? Being that everything is at the mercy of the tracking space, it gives you values relative to the tracking space, not the head. What do you think will happen if I attach everything to the head? We'll see an example in a second. Basically, the controllers will follow your head around, which will be very weird. These are only logical objects, so I'm going to add meshes to them so that we can see them. I'm going to change the order a little bit. Oh my god. I can't see, there's a really tiny screen. Okay, cube. I'll make the left controller a cube. It's really big right now. I'll change it in a second. I'll make the other one a cone. I'll make them both really small. 0.1. There, I have a cube and a cone. There's a cone in there. So this is an Unreal specific thing, so I wouldn't worry about it if you're not going to use Unreal, but in Unreal you basically have to tell the engine which pawn is the one that you want to use. So just dragging the Nick VR pawn into the scene doesn't actually give me control over it. I need to tell Unreal which is the pawn that I want to use, and you can do that in the level blueprint. So I'll just do it quickly. People who are working in Unreal can worry about this. I won't. So for the people who are working on Unreal, basically in the level blueprint you set things up and you just define how things relate to each other. So in Unreal you specifically have to say that the player 0 needs to control this thing instead of any arbitrary thing. Does that make sense? Like, I believe Unity just kind of finds a specific camera or something like that. Does anybody who knows Unity well know? It kind of just finds something called main camera, right? It's harder to define what specifically is the player character. But anyway, this is how you just make something do something. All right, so if I play it, we'll see. I'm a VR guy. I'm stuck on the floor, but I'm there. Here's my cone. Oh God. So yeah, it's parented to my face. So I'm not moving my hand, but this is what's happening. Because all of the values are supposed to be relative to the tracking root, not the camera. That hopefully makes sense. So I don't want things to be parented like that. I just want them to be themselves. Oh God, why did it select that selection? It just selected a bunch of random things. Okay. So now I have it right. I'm gonna move it up a little bit, just so that it's eye level. So, yeah, I have a cone. So, we did that. Also, I have this, but I only have so many hands. I also have a cube. So, let's start the shooting game part of things. I want to shoot with my left hand. So I'm gonna use, instead of the cube, I want a ray gun mesh. I already imported one. That looked pretty good. It's this. See, it's just a ray gun. I'm gonna use that instead. Unreal has this cool feature where you can click on a mesh and then go in and add static mesh, and it knows which one you want to add based on which one you have selected. So it already knows to add ray gun, which is convenient. Alright, so I'm gonna add this ray gun. It's really tiny because I scaled it relative to the cube. Alright, there. And I'm gonna make it gold. Okay, that looks pretty cool. So you'll notice something when I play this, or you won't notice, but this will be really obvious to me. For me, this is the size. For me, I noticed that if you look at the pivot, it's actually pivoting around like the middle part of the gun, not the handle, because of where I positioned it. So by default, the tracking, this left controller thing is in the middle here. So that's also where the ray gun should be. Like, I want the pivot of the ray gun to be where this is. Does that make sense? So now if I play it, it'll be in the right place. I can tell Unreal is compiling shaders because I can hear the fans moving. So yeah, now it's in the right place, kind of. It's good enough. It's a ray gun. They don't exist. So yeah, now I want to get key input. Because you all, or most of you except 5 of you, did A2, you should know how to get key input. I can do it a couple of ways. I could just do Oculus Touch, right? But Unreal tries to abstract it more, so they won't let me do that. Both Unity and Unreal have some input section where you can manually define things. So what I did, let me X out my old work. There were some default options for the default scene, like how to teleport and stuff like that. They didn't actually define the triggers though, they defined the grips, which are these, like LB and RB. So I can define an input called shoot gun. You have no idea how small this screen is and how low resolution. Oculus Touch, right, or L trigger. There, this is the left trigger of the Oculus Touch controller. So now I can get shoot gun, and this is an input that gets called when I hit the button. Now how do I know if it's hitting it? I'll show you my favorite troubleshooting strategy of attaching a 3D text to your face. If you recall, I mentioned that you can't actually focus on a 2D UI, so you need to use 3D. So I'm gonna add a text render. I'm gonna attach it to my face. I'm gonna center it. Oh God, Unreal. You can hear the fans. And I'm gonna make sure I could see it. So I'm gonna print out on this text object whether or not I'm pressing the button. So I have this thing, get a reference and set text. And when I press it and when I release it, I'll say something different. So set text, just to verify that it's working. 3D text are probably going to be your best troubleshooting strategy in VR, so you don't have to keep leaving and looking at the console. So when I press the button, I hope that even if you're not using Unreal, the black box nodes should make sense. Like when you set the text of something, its input is what that text is. Like I hope that makes sense even to the people who are not using Unreal. Anyway, I'm gonna say shoot when it's pressed, and when it's not pressed, or I mean when I let go, I'm gonna say release. I can't tell if I spelled it right from this screen. So now, this is not how you wear the headset, but this is so I don't have to keep adjusting it. Pew, pew. This is how I can control things. So I can handle the actual shooting the same way. So I need to shoot bullets, and it doesn't know what a bullet yet is because I didn't tell it what bullets are. So I can make a class that's for bullets. I'll just make some actor that's called bullet BP. And by default, it's not going to have anything. Same as in Unity, like the default game object has nothing but a transform. I'm gonna add a little sphere to it. And I'm gonna make it smaller because it's going to be gigantic right now. And I'm gonna make it more ovally like a bullet. Yeah, that's a bullet. And I'll make it red. So it looks like a baby carrot. Alright, so I'm gonna shoot these. Unreal and Unity both have a spawn actor, or they have some kind of spawn function. In Unity it's called instantiate. In Unreal it's called spawn, so I'm gonna use spawn actor from class. I wanna spawn a bullet. Bullet BP. I'm gonna tell it to always spawn no matter what. And it needs to know where I'm going to spawn it. Let's say naively, I'm just gonna spawn it where the ray gun's origin is. So I can say get actor transform, or get world transform because it's a component. So this is some object like in Unity that has location, rotation, scale. You'll notice something pretty cool when I do this. Well, you'll notice a couple of things that are wrong. So, pew. Remember the origin of my gun is not, it's like near the middle part somewhere. So that's one problem. Another thing is that they're not moving or doing anything. I'm just spawning baby carrots. They look cool though, they have nice shading. So I need to make them do stuff. So a couple of things, there are tricks to getting, so I want it to spawn over here. But I don't know where that is myself. I could just calculate it and just add that transform. That's not really a great or modular way to do things, because if the mesh resizes or something, it'll be in a completely different place. So we can use parenting. So I'm going to use a little cone that'll be like a pointer, or not a programming pointer, but like a literal thing pointing at something. I'm going to make this small little cone, and I'm just going to position it and point it to where I think things are. So with the cone, the up vector is actually like the pointy part. We'll see why that's important in a second. But anyway, oh whoops. So now, this thing is where the bullets should shoot, and it's pointing in the direction that they should shoot. Make sense? So, in my code, instead of using the ray gun's transform, I can use the cone. And because of the parenting structure, you can see if I move this thing that controls the tracker, everything follows, because that's how parenting works. So the cone is safe, is a safe place to spawn things. Like I know it'll move with my arm. So I'm gonna spawn this where the cone is instead. We'll notice some pretty interesting things though. Oh my god. Phew. So, not only are they way smaller, but they're not facing the right way, and they're still not doing anything, but they look nice. There are a couple of reasons for that. First of all, I rotated the cone sideways. So the bullet, if you look at the axes, so this is in local mode. In Unity, Y is up. You remember the transformation system, so just think of that when you're looking at this. But Z in Unreal is up, which represents the up vector. Red is the forward vector, and green is the right vector. And I've rotated it, but the bullet it's still aligned with the world origin. So I need to rotate the bullet so that it works with my gun. That's one problem. And the reason why it turned tiny is because when I did this, remember a transform also includes a scale. And the cone I scaled down, which means that the bullet is at 10% of its size. So I actually only want to keep, well, so in Unreal you can break transform and get the 3 components. I want its location. I'm going to make a new transform that I'm actually going to use. I want its scale to be 1, 1, 1 because I want the bullets to be the size that I gave them. I want to keep the location because the location was good, but the rotation is wrong. So this will be the new thing. The rotation is wrong. It's sideways. So I want the bullet to point the same way that the cone is pointing, right? So I need the cone's up vector. I could say, from the cone, I could say get up vector. And this will give me that vector. It doesn't give me a rotation though. Both Unity and Unreal have functions that will get a rotation from a vector. So if a vector is pointing some direction, what kind of rotations do you need to get to that vector? Does that make sense? In Unreal, it's called make rotation from X. And this will give me the rotation that will make this thing point in the direction of the cone. So I'm gonna have bullets. Thank you, Oculus, for losing the tracking. Pew, pew. They're still really big, but I wanted them to be big. So you can see they're facing the right way, and they're the right size, at least as far as I want the bullets to be. Bullets aren't usually bigger than the barrel of the gun, but you know. All right, now I want them to do stuff. I need to add physics. So by default, I just added a mesh, but so like in Unity you have to add a rigid body. In Unreal you need to check the simulate physics. Those have the same effect. They let gravity and stuff work on the object. So for now, let's say I naively just say simulate physics. So we'll see what happens. Pew. So notice a couple things. First of all, they're rolling off the cone. Another thing is that they're not doing anything. I could probably like shoot it upwards and hit it like a baseball. Yeah. That's not really how bullets work. So I need to fix this. There are a couple of things that are wrong. First of all, at least in Unreal, meshes by default have colliders. So both my gun and the cone have colliders. So I need to remove these. And Unreal settings are here. So Unreal sets everything to be block all. Unity does too, but for primitives, I don't think it does it for regular meshes, but it's a technicality we don't have to worry about. So now, if I do this, pew, pew, pew. Oh, they're still rolling off the cone. I forgot something. Did I? Oh, yeah, I did. I forgot to check it. Alright, I'm good now. Alright, so now, they're not going to roll off the cone, but they're also not going to do anything. They're very limp baby carrots. I want them to do stuff, so I have to... The bullet doesn't know how fast to move or where, right? I only spawned it. So I need to tell its physics system where to shoot it. And so Unreal and Unity both have this function that's like, it adds impulse. So it basically tells it how fast it should move. Add impulse to the sphere, yes. Physics in Unreal is done on the actual like mesh. It uses the mesh as like information about how to apply the force, but it doesn't matter. So I'm going to add impulse, and it needs to know where to add the impulse. I want it to shoot in the direction that the cone is pointing. So that's a practical use for this cone right here. It tells me how to orient the world when I don't already know that. So I'll do this. Velocity changes just adds physics and stuff like that. It doesn't actually make a difference here. So you'll notice something. It's still not doing anything. And the reason for that is because Unreal's units are in centimeters. Are you good? Unreal's units are in centimeters. So if you remember units of impulse, they're like, it's like mass times velocity. And in Unreal, velocity is going in centimeters per second, which is very little force. So I can just multiply the up vector by some value, such as 1,000, and that'll give it a lot more force. Is that 1,000? I can't read that. It's a great screen. It's not only low resolution, but it's also distorted. So now, pew, they shoot, but they're very weak. I can barely knock over the blocks. The reason for that is because I didn't change the mass of the bullets. There's still like the default mass, which is like, I don't know, 1 gram or something like that. In Unity and Unreal, you can change the mass inside the rigid body setting somewhere. So like I'm changing it in mass scale right here, which just multiplies the mass by 100. And thanks, Oculus. Okay, pew. Yay. They still spin, which isn't really how bullets work, but you can make them kill themselves and stuff like that. But that's on you. I want to do one final thing. I want, when the bullets hit these cubes, I want the cubes to change color. So this is a good use of, you remember Unity and Unreal both have a function for hitting things in terms of the physics sense and triggering things in terms of like overlapping. So that's what we're going to use. When the bullet hits something, it needs to change that thing's color. So the interaction is between the thing it hits and the bullet. The thing it hits are these cubes, and in Unity and Unreal you both have to set some options to make it trigger certain things. The cubes are already set to generate the hit events. I didn't set my bullet to, so now the bullet will, I enabled hit for the bullet, which means that they'll have reciprocal calling of the functions. So in Unreal you have event hit, which is basically the same as on collision enter in Unity. It tells you what you hit, where you hit it, and so on. And so I only wanted to change the color of these cubes, which are of this class in Unreal. In Unity, what you can do is try to get a component and check if that component is null. And if it is null, then that means that that thing is not of that class. But in Unreal, I can just try to cast it, which we do in most other object-oriented languages. You just try to cast it. So the other object, I'm going to try to cast it to that type of cube. And if it succeeds, it'll go through this path. Otherwise, it'll go through this. So if this cast succeeds, I'm going to change its material. Set material. And it's going to do this. I'm going to set it to be this colorful material. And we'll see what happens. Oh god, okay. Pew, pew. So that's why it's useful to know your collision functions. Because imagine if you had to hard code all of these cubes the way that you did for your collectibles. That would become harder and harder the farther you get into creating your features. So these collision methods are a really good way of figuring out what is what when, you know, things are overlapping or you're doing some kind of physical collision or something like that. All right, so that's the extent of my gun mechanics. Any questions before we move on to teleportation? Yes. The cone? The cone is just a visual aid. What you can optimize it a lot. You really only want a vector. It's just that a cone, since it's a physical shape, it's really easy to tell which way it's oriented. Like if you want, like in Unity, what people do often is use, create empty child. which gives you a game object that simply has a transform, and you can get the transform from that. The cone is just useful as a visual aid when you're first creating it, because I know which way a cone is pointing, right? If you want, you can just, you can do, in Unity, what you could do is disable the mesh renderer. In Unreal, there's a variable for is visible. And I can just set all these to false, and it will only show me my gun, but logically it's still pointing in the right direction. Which one is which? Oh, this is left. That's why I'd recommend keeping the stickers on. See? No gun, but it will still shoot in the right, I mean no cone, but it will still shoot in the right place. And also, because I'm casting it to this specific class of cube, and these are just generic meshes, it doesn't change the colors of those things. Does that make sense? But if I wanted to, I could try to cast it to a static mesh of some type, and then do it that way if I just wanted to change the color of anything that I hit instead of these specific cubes. But does that answer your question? Any others? All right, teleportation. I still want to use my cones, and I did attach a cone to the right controller. If you remember correctly, it wasn't actually facing where I was pointing, so I'm just going to rotate it so it is. So I want to make it such that I can point somewhere, click a button, and I'll teleport to that position. Does that make sense? So I want to use the trigger again, just because. So I'll add another input in the settings. I'll say go to there. Oculus Touch trigger. The Oculus Touch has a lot of interesting options. Actually, most of the Oculus devices do. Like, you can get some amount of pressure and stuff like that. So there are actually a lot of inputs. That's why you see so many things when I type Oculus trigger, because you can get other things that are not just button presses. But anyway, I just want the trigger. So when, let's see, I can make another event function. In Unity, this would be like input.getDown, or was that input.getKeyDown, was it? Unity also has input.getAccess and stuff like that. Unreal just has these events, which are pretty convenient. So when it's pressed, I want to shoot a ray. We already learned about raycasting, and I want to go there. Unreal calls it line tracing, and I believe the reason for that is because the parameters that you give it are different. Unreal asks you for the beginning and the end of the line segment that you want to trace, but Unity asks you for like an actual ray. It asks you for the location of the tail, the direction it should point, and how far you want to shoot the ray. So that is like more traditional raycasting, but Unreal does like an actual line segment. So I want to shoot a ray from my hand. Get the little location. This is the location of my hand, and I want it to end some distance from where I'm pointing. Does anybody remember your vector math? How do I get, if I know something is oriented a certain way, like my hand, how do I get a point that's in that direction? Anybody remember linear algebra? Yep. So if you have a location, you can add the direction, and that will give you a point that's projected in that direction along that vector. So the cone is pointing in that direction, and I know that its up vector is the direction because that's where the pointy part is. If I were to add these two, the resulting vector is one unit vector in that direction. So if my hand is pointing this way along that direction, it'll give me a point that's like right here. Unreal is in centimeters, which means this will only give me 1 centimeter of a raycast. I want the user to be able to teleport really far. So I can multiply the vector by some, I can multiply it by a lot. Let's say I want them to be able to teleport like 100 meters or something like that. And this will give me a vector that's 100 meters in that direction, wherever I'm pointing. So this will be the end of the line trace. Unreal asks you for object types, Unity doesn't. Unity asks you for a layer mask, which is kind of different. This is something that's not worth talking about, but Unreal and Unity handle the way that different types of physics objects interact with each other very, very differently. Unreal has these object types, and Unity has object layers, which basically describe like which things can interact with other things. It's not worth knowing right now. But for example, if I did want my gun to have physics, I could use collision layers to say that the gun can still have physics, but it shouldn't interact with the bullets. Does that make sense? It's not worth knowing right now. Anyway, what was I even doing? Oh yeah, so I can make an array. I only want the user to be able to teleport to static things like the floor. We don't need anything else. Unity tries really hard to stop you from drawing rays in the game. Like in Unity, you have to go out into scene mode and then look at the rays. And Unreal, you can just draw them, which is convenient for a tutorial. But anyway, for now I'm just shooting rays. So let's look at it in action. And I'm using my right controller, which, okay, there it is. Shoot, pew, pew, pew. So those red boxes are where it actually hit. And you can see it's not actually returning anything for these cubes because they're dynamic. In Unreal, that green ray represents the rest of the trace, but the red ray represents the trace until it got to the point that it hit. There are a lot of different raycast options. We'll see more on Wednesday that are useful. But anyway, this returns, if you remember the raycasting lecture, this returns a bunch of stuff, such as what I hit, where I hit it, and things like that. So I only need the location parameter for now. I want to set my own actor location. Remember, I can't set any individual thing because those are at the mercy of the tracking system, but I can shift the user's entire space that way. And that's the only thing that I really have control over as far as like tracking controllers and stuff goes. So I want to move the entire physical space in the virtual world to be wherever I point it to. And I want to move it to this new location. Make sense? I got a location for the raycast, and that's where I want the user to go to. We'll see that this is actually quite easy to break because I'm accepting any proposed position. Pew, pew, I'm stuck in walls and stuff. And remember that the user actually has a lot of flexibility. Like, imagine what changes. Like, I can move my hand up here freely and shoot downwards, but I can also do it from under here. So you can imagine that breaks things in VR because you can't control what the user does and when, because they have that flexibility. So in VR development, you have to handle this flexibility that the user has that you don't really need to worry about in regular games because you have like collision boxes and stuff like that. So, yeah, okay, the Oculus just turned itself off as I put it on. Anyway, you can see I can just like shoot through everything. Easily breakable. So, as an initial solution, let's say that I don't want their height to change. I only want to accept the X and Y value of the resulting position. So they'll translate along the ground plane here, but their position won't move, like their height. Their head will still be in the same place. We'll see what happens there. So
Do we not have gravity or something? Do we not have physics applied to this?
imagine what would happen if you were a VR character and physics were applied to you and you could jump or something. Imagine how sick that would make you. If you felt your body was not moving, but in the game you were. We'll talk about like physiological responses later, but for now let's assume that they don't have gravity of any type. Like they can't jump or anything like that. Like there's no button to just jump them. In Unreal I can just break the vector. So I want the X and Y value of this resulting location, but I want to keep my own Z value. So I'm gonna make some vector. In Unreal, in Unity, you would just like construct a vector with these parameters. So I construct a vector with X and Y of the new location and my old Z, so that my Z doesn't change, my height. In Unity, this would be Y. So if you switch engines, you should be wary of that. So this helps a little bit. Pew, pew. So I can't go through the floor anymore, but I can go through the wall. Because, the wall is here, but I can also just kind of go through it because nothing can stop me from doing that. There have been a lot of implementations to try to stop this. For example, in Surgeon Simulator, what they did is if you try to put your hand through the body and just shove it through some arbitrary way, your hand mesh will get stuck outside of the body, and your actual tracked hand turns into a skeleton, and it goes inside, and you can't get it back until you come back out. So that was a cool implementation. A very sickening implementation that I saw before, that was an interesting idea but didn't work very well, is they put a collision box on your head and made it so that when you try to put your head through a wall, the entire world moves. And that made people very, very sick. So we're not going to do that. We can actually use a smarter way of doing it. So we'll talk about AI much later, but when we tell an AI to go around places, there's a thing called a navigation mesh, which we can use to constrain which areas are safe for it to move. So in Unreal's VR default scene, they already have one. You can hit the P key, but this mesh shows you which areas are safe for an AI to move. But you can actually also use it to say which areas are safe for the user to teleport to. Because as you can see, the safe area is some distance away from the wall. And so I actually don't need to hard code anything. I can use the navigation mesh information to say, oh, that's a safe area, let's go there instead. So in the code, what I'm going to do first is just make a variable that I'm going to expose that I'll call navmesh, and it's going to be of type navmesh. And Unity has the same thing. I can't spell. It's this. I'm going to expose it so that I can assign it from the editor. I just want a reference to this green thing, which we'll see in a second has some really useful functions. So, make VR pawn. Did I forget something? I forgot to compile. There it is. So I made a reference to this, weak pointers. Most of you did A2, so you should know how this works. Nav meshes have really nice functions. So if I get some reference to it, it has a nice function, for example, called project point to navigation. And what this does is it takes a vector and it finds the nearest safe points on the navigation mesh. And I can use that to figure out what is safe for the user to teleport to. Okay, the monitor just turned off. So I'm going to use my proposed location wherever I recast it to. And I'm going to try to find some space within a meter by a meter by a meter. It basically traces around a box. Actually, I'll make it 10 meters because I don't know that this is 1 meter. It's hard to tell. Let's say I try to find within a 10 meter cubed box window where is safe for the user to teleport to. That will return to me a safe location, and that is actually what I'll use for the X and Y values. Does this make sense oh god. Does it make sense what this is doing? It's basically, the raycast gives, yes?
I was wondering, is the nav mesh something that's automatically generated, or do you have to define that and make a new scene?
In Unreal, there's this class called navmesh volume, where you define like a giant area for AI to walk, and you can, then there will be like, at least Unity has a similar system, but it's in a different place. But like Unreal has this thing, build paths, which will build all of the safe navigational areas, and Unity has something similar. And inside of the resulting navigation mesh, you can control things such as how big is the character. So I can make the character really fat, and it'll say that these areas are actually the only safe areas for it. Make sense? Navigation is really, really important, and we'll see it later. But for now, we're just using this convenient function. The raycast is proposing some X and Y, but it may or may not be safe. So I find a safe position that's close to it, and then I use that instead. So, as we'll see in action, this keeps me from getting stuck in walls. Controller, thank you. Pew, pew, pew. I can't find any safe areas right now because I made the character. What?
10 meters.
My what?
Your 10 meters.
Well, that's the scale that it should search for. I think the problem is that I made the character too fat, which means that the navigation mesh is like more than 10 meters away from the wall. You can make the search area can be any arbitrary size, but then it may just find a good position that's like its good position might be really far from the wall. If you just made it some unbounded box search area, it'll just find a good position. Well, it's projection. I think navigation meshes are really smart nowadays, so it's still a projection onto it. Like if you took 3D, well, most of you should have taken Calc 3, so you would have remembered projection onto a surface. if you remember that method, that's kind of what it uses. There is a navigation mesh algorithm that we'll talk about much later, but as you can see, this is doing a good job of keeping me away from the walls. And sure, I can keep going into the wall, and you can keep editing the navigation mesh, but it's harder. And like, this is where my table is, so, as a user, I wouldn't be very tempted to go this way anyway. And so yeah, now I can navigate my scene safely without getting stuck in stuff. And I can also shoot things. Pew. Yay. Look at that. It's beautiful. Does all that make sense to people? Why that works? It turns out there's a very small amount of stuff that we need to hard code. We can just use information from the game engine to figure out safe areas. We don't need to hard code anything really. There's very little actual math that we need to do. If you think of nodes as lines of code, this is what, 1, 2 lines of code in this function, and the shooting gun function is what, 2, 3, 4 lines of code. And sure, maybe in the C# or C++ implementation, it's a little bit harder because, you have to cast things and all that kinds of stuff. But the point is that you can make really cool things happen with very little code. And so it's learning these modular methods like collision detection and raycasting. We have a few minutes left. It's not enough time, but next week, on Wednesday, we'll talk about how do you grab these objects and how do you move them around and how do you be able to throw them and stuff like that. So yeah, it'll be cool. And by Wednesday, all of the methods that you would have learned by the end of Wednesday will be applicable to almost any VR feature that you create, because raycasting and collision detection are two of the most common ways of figuring out some arbitrary environment. You just, for each actor or game object, you set some parameters, such as how it collides and things like that, what it looks like and so on. And then you can use these automated methods like raycasting and collision to figure out the scene itself and how they relate to each other without hard coding things. So, yeah. All right, well, any A3 questions? All right, I don't know why the fans are going. I guess Unreal is compiling something. All right, well, bye. Good luck on A3.